Well, good morning, good afternoon, good evening to everyone, everywhere you may be, anywhere across the world. Thanks so much for joining us live here on Serverless Office Hours, same time, same place, streaming on the AWS Twitch channel, Serverless Land YouTube channel, and also on LinkedIn Live. LinkedIn Live. They've been already swallowing my words. My name's Julian Wood. I'm a developer advocate who works at AWS as part of the serverless product team. And today I'm super excited. That's me on the left, by the way. Yeah, hair looks slightly different over the lockdown. But anyway, I'm so happy to have Ben Ellaby, who's one of our amazing serverless heroes and who's not a senior developer advocate at all. Copy and paste error. Apologies, Ben. But yeah, Ben is more importantly the founder of Alios. Welcome to Serverless Office Hours, Ben.
Thanks so much, Julian, and good to see you again. I know we saw each other at the AWS Summit last week.
Yeah, exactly.
Good to see you virtually.
No, we had some amazing conversations last week. One of them with Ben, which led to all the cool ideas for today. So yeah, Ben and I have known each other sort of, I suppose, since I started at AWS. Ben, you sort of companies based in London, so yeah, we're sort of locals, which is pretty cool. Cool. So Ben, how did you get into serverless? That may be a bit of an oddball question, but I mean, you are one of the leading lights. When did the light sort of turn on for you?
It's a good question. I should probably have an answer in my head for that.
I should have prepared too.
No, it's good. I mean, I've worked in sort of software consulting for a long time now. So I was previously at a company called Theodo, and Alios is actually part of that Theodo group. And I worked with clients ranging from startups building their new sort of products through to large enterprises trying to compete with startups, and sort of did a lot of building of web and mobile applications for companies in a traditional server-based approach, then more in cloud, and then more in serverless. And we were starting to use Lambda for some of our projects for some sort of cron-based tasks and some other parts. But one day we decided, let's go fully serverless for a few client projects, because I was really enjoying not managing SSH keys actually. And then gradually over time, other advantages definitely came. So yeah, we started running fully serverless projects on AWS for our clients. And then we actually started writing and sharing what we were doing. We have sort of an open source blog called Serverless Transformation, a few open source projects, a bit of tooling, SLS test tools, SLS dev tools. So all of that culminated in people starting to come to us to do some serverless projects. So we actually spun Alios out as a fully serverless focused startup a year ago now. And we've just been doing serverless projects since then. So a long answer, but yeah, it started with a bit of Lambda and then ended up 100% serverless first.
Fantastic. No, and we're going to explore a whole lot of those things today. While we were chatting, that was part of an opportunity to remove your senior developer advocate. You are the amazing Ben Ellaby, founder of Alios. So yeah, just looking back over the past week in all worlds of serverless before we get back straight into what Ben's going to be talking about today. Last week was actually a crazily, superly fun show. Ben Smith and I, who are also based in London, we were also at the AWS Summit last week, and we rushed back to do this. And as gremlins would have it, we had ultimate tech issues. Everything partly went wrong, and so you basically can look back and look at the new cool functionality of Lambda function URLs. But Ben and I get to pair program on this one because Ben's laptop wasn't working for sharing his screen, and so he was basically telling me what to type. And amazingly, we got through it all. And the people who were watching were also super useful in spotting our spelling mistakes and helping us. So remember, this is live. We love your participation. Please send us your comments, send us your questions, send us anything. Let us know where you're from. We'd love to find out who's listening to watching Serverless Office Hours. In terms of what's new in the world of AWS Serverless over the past week, I mentioned function URLs. These are really cool, simple HTTP endpoints built into the Lambda service, really easy to use for your functions. Kinesis data file hosts can deliver to CoreLogix. Slightly older news, but Lambda, remember you can have now up to 10 gig of ephemeral storage. That's /temp for the likes of you and me. And some EventBridge as well has got the cool new functionality for global endpoints, which allows you to fail over and recover your events all over the globe, which is pretty cool. And Step Functions coming out with more SDK integrations. In terms of compute blog posts, Java is one of our super important runtimes here at AWS. But Java, as you know, has got a big history, and it means there's a lot of sort of tweaking and tuning you can do to really get your Java to fly on Lambda. Some of them to do with environment variables, variables that you can do. We recently spoke about a blog post that Mark Sales had done. And this is another way where you can build a custom Java runtime for Lambda. And Christian, Maximilian have really put together some really cool stuff. If you're building with Lambda, AWS Lambda Power Tools is an amazing set of utilities. And Jerome van der Linden's got a cool blog talking about functions idempotency. So when you can make the same call twice and without making any changes. And this is, making any changes to the end system. And this is a way you can understand idempotency and how you can use it with Power Tools. And Stephen Leidig's also got a cool blog post on global endpoints. Tali Anassi on my team as well has been working on some slightly more beginner content to help you to introduce the concept of events and how you can use it with EventBridge. And some of those cool things we're also going to talk about today, how to think about events with Ben. Ben and I alluded to the AWS Summit that was in London last week. It was actually incredibly, amazingly, and slightly weirdly to see so many people in one place. Ben, what was your sort of thoughts of the AWS Summit, other than I don't actually know how many people there were. There seemed many thousands. And it did seem slightly weird when we're not all used to it. But it was a fun event, but I can imagine it's probably overwhelming for a lot of people.
Yeah, it was great to see people in the sort of serverless London community back together all in one place. Some really good talks. I really enjoyed the keynote that featured Bob Gregory from Kazoo, speaking about how they built the whole startup using serverless, which was a really great story. And the serverless espresso was going as always. So thanks to you and the developer advocate team. It was really great to see that working when the Wi-Fi was up. But it was a really great event, some really great talks, and good to see everyone together.
Yeah, cool. And it was the Serverless Espresso, which is our sort of how to explain events and orchestration and choreography and a bit of Lambda and API gateway and all these kind of things. And basically you get a free coffee out of it at the end. And the whole back-end workflow is built with serverless technology. So it's a really cool way to illustrate how you can build serverless tech. And it was actually in a nice position. And so we had serverless heroes and we had customers and we had other colleagues and everyone standing around and, really meeting each other in person after many years. But, that is all going on the road. We've got colleagues in Madrid starting tomorrow who are going to be doing Serverless Espresso. So that's Madrid. There's Stockholm coming up. I'm actually going to be Berlin. I think, Ben, you're going to be in Berlin as well.
Yes, I will with some of my team.
Cool, excellent. I'm also going to be in Milan, which is further down the list. There are one or two, I think, that haven't quite made it onto the list yet. Zach Jones-Noel, you have also mentioned AWS Summit India is missing on the list. Sorry for that. I didn't spot that. That's a virtual one, apparently on the 25th and 26th of May. I know there are some other virtual ones. Maybe I missed that out. Apologies, Zach Jones-Noel. Thanks for keeping me honest and making sure all the list is up to date. But AWS Summits, free events to go to, huge amounts of content. Some of them are even spread over 2 days. There are also workshops to do. So I really encourage you to sign up, and my whole team will be there at all of them, at most of them, or at least the European ones will definitely be there. Still working on the American ones. But come and ask us your serverless questions, find out about Serverless Espresso. It's going to be all good. So that's the past week. Now, today, I'm super excited because something I've been sort of discussing and noodling over in my head over many years actually has been all about EventBridge and EventStorming and minimal viable migrations. And Ben is going to explain what that is all about. But I actually referenced the EventBridge Storming in a reInvent presentation I did last year, because many people ask me, okay, there's a sort of step jump you do to go, the cool thing about serverless isn't necessarily that it's just serverless, but actually that it's event driven. For me, that's actually the crux of what serverless is. And actually when Lambda was announced, there wasn't a concept of serverless. That just didn't exist. And Lambda was announced as an event driven computing. So we sort of, 7-ish years later, we are talking a lot about events, but people do come up to me and say, okay, I think I'm getting this event kind of thing, but I don't know where to start. And this is when Ben comes in talking about EventBridge Storming. So Ben, over to you. Can you explain what are we going to be talking about today?
Yeah, of course. And I've got a few slides that I'll share, and then we're going to jump into actually doing some EventBridge Storming. But EventBridge Storming, it's a workshop inspired by EventStorming, unsurprisingly, which is an extension to domain-driven design. So we'll go through how we can use that to architect our event-driven architectures. The other thing that I think is interesting is adopting serverless when you already have some legacy. So I'm working with several large enterprises at the minute that actually have on-premise, and they're jumping all the way through to serverless on AWS. So even if you're not going from on-premise, but how do you do that jump? How do you go from legacy to serverless. And the solution is really event-driven architectures and what I call minimum viable migrations, very similar to sort of the strangle a fig approach. But that move to more event-driven architectures also kind of arrives as at a sort of non-terminal architecture where we can keep adapting as technology changes. I think things are going to move even more serverless over time, but how do we keep up as things change? I'm just going to share my screen and we can jump into some slides.
Certainly, I'll add that in. Yes, that is the whole concept, that if you're running from a standing start and you're building a new application today, well, I would certainly say, and Ben would probably certainly say, well, at least consider serverless for as much as you can. But yeah, if you are, changing things or moving from some legacy, and it may not be only on-prem, this could be EC2 instances, this could be containers, this could be sort of any traditional architecture, and I don't mean that in a pejorative sense as well. These are applications that are up and running, that are making money, that are doing cool new things, but you want to do some more with it.
Especially, and it's not a lift and shift to serverless, and I think that's where people get put off, and where we need sort of different strategies to do that. Let me just jump into the slides. So my name's Ben. I think we've gone through all of that. If you want to learn more about EventBridge Storming or minimum viable migrations, you can find that on the serverless transformation blog on Medium, and you can also find it on the Alios website. We have a number of open source projects as well, so you can find all of that on the Alios website or on the Medium serverless transformation. But I think what me and Julian were just talking about is this idea of moving towards serverless microservices. So as you've probably said, as has probably been said many times on this channel, serverless is not just Lambda, it's a collection of services like DynamoDB, step functions, EventBridge, S3, that we can combine together to build these serverless microservices. And there's a real trend for people to move towards event-driven architectures and event-driven serverless. So putting something like EventBridge in the middle of those microservices and having those independently deployable microservices, pushing events onto EventBridge, and also retrieving events from EventBridge, or having events sent from EventBridge. And this also has an interesting element in how we structure our teams. When we want to scale large engineering teams, I have a team of 100 engineers, not from my company, but there's a team of 100 engineers working on a system that we're involved with. How do you get those teams to deploy independently, to work independently in a serverless way? And event-driven architectures with independent services is sort of the key step to allowing that autonomy and reducing the cognitive load so people can work independently and deploy independently with that shared contract of events.
Yeah. Ben, I just want to jump into that. It's something, even, talking to loads of people in our Serverless Espresso booth last week, which is very much Lambda and EventBridge and step functions, and some people trying to sort of understand when they should use EventBridge and when they should use step functions. Now, actually, I know what I would say to that. What would you say to people who asked you that?
Oh, sorry, just broke up a bit there. Could you repeat the last part?
Yeah, sure. When you would use step functions versus EventBridge, lots of people talking about this concept of orchestration versus choreography. Yeah. And I'm not actually a big fan of the word necessarily on the choreography, because I don't think that quite elicits what EventBridge. I don't think it's the best word we can use to describe EventBridge, or eventing for that matter. It doesn't have to be the product name EventBridge. But yeah, what do you think about explaining to people when you would use EventBridge versus step functions?
Yeah, I think a useful metaphor for this is kind of thinking about database transactions. So if you want something to kind of happen all together, and it's not exactly atomic in the way that a transaction is, but it's one thing you want to happen, it may have several steps, but it's all related to the same entity or collection of entities. And it feels like a business process that is a unit, a business process that is defined. A step function makes a lot of sense. And we're going to come on to domain-driven design and how you structure different bounded contexts, and therefore different microservices inside of those bounded contexts. But as soon as a business process moves between two different bounded contexts, between two different microservices in different areas, and maybe just to take it back to sort of more business related terms, if you have a marketing department and you have a payments department, and you want to send an email after every successful payment, and you want the marketing team to have that responsibility for some reason, it wouldn't make sense to have a step function that goes from the marketing service through to or from the payment service through to the marketing service. They're independent teams that are deploying independently, and they're independent services with different representations of data about customers. So it makes a lot of sense to make that decoupled, to make that go through EventBridge. Whereas if you have something that's very tightly coupled, when the order is actually placed, you want to send the email, and you don't view that as marketing's department, you view that as a confirmation. It's a bit of an arbitrary example, but that's happening inside the same department, and you want it to happen inside the same service. It makes sense to happen together. So I think thinking in terms of business processes, and when those business processes span multiple departments, can be a useful trick to try and think when something's happening completely decoupled compared to where something is coupled in a good way in a set of steps that you can have failovers and choice and logic around. I think that's a good way to think about it. But I think also it's not, it gets complicated because it's not just a split between, well, it's not a split between synchronous and asynchronous. Step functions can be very asynchronous, and you can have an email scheduling system that waits 6 months to send an email. That's still one process that's happening inside of one department, inside of one logical unit of your company. And I think what makes this even more interesting is those direct integrations that step functions can support, because we have a very low, almost a lambda-less approach to sort of building these business processes. And then we can have EventBridge between all of this that's kind of making sure that when this process ends, an event is emitted, and then other teams can decide to react to that event when they want to.
Yeah, no, love the explanation. What prompted to me is on the slide, you have a EventBridge between these 4 different microservices, and you've actually got 2 step functions within 2 of those microservices. So yeah, I wanted to hear your really good explanation. And so, a workflow, something like step functions is generally within a microservice, as you were talking about the bounded context. So didn't want to distract you too much, but it is something that people are thinking about.
No, I think it's really interesting, and there are definitely edge cases on that. And yeah, keep jumping in. So, people are moving towards these event-driven architectures of serverless, but people aren't there already. So how do we achieve cloud migration and modernization? And not to dwell on this too much, but what do we mean by cloud migration? Well, it's the process of moving digital businesses, assets and operations to a cloud provider, or from one cloud provider to another cloud provider. Application migration is the process of moving an application to a different environment. And this is all just changes of paradigm or changes of domain, which we'll come on to in a minute. But there are a few sort of traditional approaches to migration to the cloud, or migration in general inside of the cloud. There's rehosting, that's a lift and shift. Refactoring, which is changing existing code to put it on top of more abstracted infrastructure. It's a good way of thinking about serverless. Rebuilding, which is often serverless requires even more than just a refactor to go ahead and rebuild. And then replacing, so deciding, what, we don't need to do our email sending anymore. We're going to bring in a third party, or we don't want to do our push notifications. We're going to use Twilio to decide we don't want to build that core capability. And with a move to serverless, people often move to try and sort of buy, not build, when they want to have a new feature functionality that's commoditized. Much as we don't want to run our own servers, we don't necessarily want to run our own notification systems. But those third-party systems often work in terms of events. They want an event sent to them, and they're going to send something back. So if our architecture is working in terms of events, then it makes it even easier to consume these other third-party services. A bit of a tangent on the replace part, but the sort of 4R model or 5R model, depending who you're talking to, for migration is typically seen as the approach. And that migration can be from any domain to another domain. So let's say we're moving an app from domain A to domain B, or we're moving it from on-premise to cloud, sort of traditional migration, often a lift and shift, as you'd see. Or we're moving it from .NET to Python. I'm not saying there's anything wrong with .NET. I'm just giving an example of a language migration, which is obviously going to require a lot of refactoring and rebuilding. And then there can be a more structural migration. You might have a very monolithic application that you want to move to a collection of microservices. Or, of course, we can move an application that's a traditional cloud application through to something that's fully cloud native and serverless and event-driven. So combining that sort of structural migration with also a change in the underlying technology. And this kind of contradicts, I think, how a lot of us work in software. If I was to say we want to build a new product, everyone would be saying agile. Everyone would say we need to discover requirements, we need to have cross-functional teams, we need to involve customers and end users. But I don't think many people view a migration project like that. As we saw, it's going from one domain to another. It's just a big bang, go from here to here. There's no intermediary steps. So we lose all the benefits of agile that we know are very useful, both for developer motivation, but also in de-risking and adding value to customers earlier. So we don't often see this concept of an MVP, which is often very related to agile. That's that minimum viable product, a version of a product with just enough features to be usable by early customers who provide feedback. And then we continue to iterate and cycle to build, measure, and learn. That build, measure, and learn cycle often isn't taken in migration projects. So the technical assumption is taken, and it's only at the end of the project that we see something fail. And we don't have that iterative cycle on a sprint by sprint basis where we can ship new features, measure, learn, and continue to build and test hypotheses earlier, learn faster, reduce waste, get the product out quicker, or get the migrated version out quicker, and validate those assumptions. And this is where that concept of minimum viable migrations that I've been using with our projects really comes in. It's in having that iterative feedback loop and moving away from that big bang migration of paradigms. So if we go back to sort of a traditional waterfall as is to be, the as is paradigm through to the to be paradigm, the app is going from one to the other. In waterfall, that's often seen as a set of steps. We do our requirements, our design, our implementation, finally verification, and everything works. But we know that often isn't the case. And we know that's not the case when we're building new products. And it's very much not the case when we're doing migration projects. And one of the reasons when we do migration projects that people move away from an agile approach is, well, partly they feel there's less assumptions made and less things to test. But also there's a real big problem of a deadlock of feature parity. If we have a system as is and a system to be, we can't go live with the system to be until we have all the features and functionality of the existing system, because our customers are going to complain. We're not going to be able to support the same features. You can't have an e-commerce checkout flow without the payment page, because how's it going to work? And this deadlock of feature parity is really what blocks people in thinking in terms of an agile approach to building architectures. And how does this relate to event-driven architectures? It's going to become clear soon, so just bear with me. But achieving that odd parity, there's some things we can do, like an opt-in beta program, removing some low-value features, or only moving some users across, like users who don't need SSO, for example. But when you have big applications, that only get you so far. What we need to do is to be able to run two systems in parallel and have an exit strategy where we can iteratively build new features and functionalities, or replace existing features and functionalities in new technology, and gradually work to shut off that old system. Very much the strangler fig pattern that people are likely familiar with. And when we're applying it to cloud migration, I've come up with, and very much inspired by the strangler fig pattern, a concept of minimum viable migrations, where we have a usable migrated version of an application from one domain to another with a subset of the features to be used by some or all of the customers. And again, we get those advantages that we have with MVP. We learn faster, test assumptions earlier, which is probably the main benefits. We also get our team to be focused on a culture of continuous delivery and continuous deployments, and we deliver that value to customers earlier. We can migrate 80% of the features to newer, faster technology. Well, that's probably 80% of the interactions users have, being faster and maybe even cheaper to run. And migrating that as is to be, if we were to look at a system with, let's say, a number of different features, so blue, green, orange, and purple being the different features, the system to be, it's not a very clear slide. I probably need to work on this graphic, but these are more opaque. They've not been built yet. We need to get through a series of minimum viable migrations to get to that to be scenario. But as I mentioned, we need to have two systems running in parallel, and therefore we're going to have a channel of communication between those systems. So gradually we can start to pick off the different features and functionalities. And just a spoiler alert, there is no real final state. Building in this way, we have a very evolutionary approach to migrating to new technology. We'll actually keep going because new technologies will come out, new features of serverless will keep increasing. There's going to be a new reInvent where some new amazing services will come out, and we'll want to keep up with those. So actually building an architecture that's actually very amenable to an evolutionary approach is going to help us be able to keep our system up to date and not have these big bang steps between technology, those big generational projects when it comes to applications. But this means modeling our system in terms of events. To be able to have two systems running in parallel, we need a communication channel. That communication channel inside our new architecture, of course, needs to have loose coupling and needs to be very decoupled. But actually, between the old system and the new system, it even needs to be even more decoupled, because we don't want the architecture and the design decisions of the old system to impact the design of that new system. And this is where we need to move to an event-driven approach. And when we talk about events, we're talking about those significant changes in state. And thinking about events from a business context rather than a technical context allows us to have an event-driven interface that actually is independent of the underlying technology and represents the real business processes. And also enables us to catch any inconsistencies in our business, which do exist, and actually model for them rather than be caught out by them when we get to the development stage. So EventBridge Storming is a specific variant of EventStorming, which, as I mentioned, is a domain-driven design workshop that reduces rework and tight coupling for teams building state-of-the-art event-driven architectures. And we can use this methodology not only to build a brand new, shiny, serverless startup that's fully event-driven, but we can also use it to figure out the events that enable us to have that migration strategy through minimum viable migrations. Now, I've already talked way too much for the format of this show. So I think what will be interesting is us quickly looking through the 8 steps of EventBridge Storming and then actually jumping over and me and Julian are working through an example of what that might look like.
Sounds
but
good.
the 8 steps being that event discovery, then temporal sequencing, a fancy way of saying putting things in order, trigger detection, which we'll skip over today, but figuring out the commands and the actors, categorization into aggregates basically being the entities or collections of entities. You can think of them as the nouns, the car, coffee, whatever the thing we're selling is. The bounded context, so categorizing, so grouping those events into independent areas of a system where we avoid dependencies. And then we can figure out on microservices, create a single event bus on EventBridge, for instance, and then actually capturing the schema of those events into the EventBridge schema registry, because that event schema is actually going to be the contract in our system. And we have teams working independently, but communicating through that shared contract of events. And the result is going to be that shiny serverless event-driven architecture that we saw at the start. So Julian, unless you have any questions, should I jump across into the exercise?
Let's jump across.
Awesome. So it's going to be a bit of a mock exercise because, well, we don't have that much time. And typically these events work best when you have representation from both the technical side and from the business side. And if you're in a startup, it's quite easy. You get everyone in a room. If you're in a large organization, you want to at least get everyone from every department or every silo. I've once done this in a large aviation industry client. We had 25, 40 people in the room together. Having these events at a large scale, it's going to take more time, but the more time we invest in this initial definition of our events and capturing any inconsistencies in our thinking will help us build the architecture that's more amenable to working independently, but also with that shared contract of events.
This is what I like about the event storming model is it's a shared exercise with business and IT. And in fact, I think you want to sort of have more business in it because you're basically trying to use events to model your business, but obviously your business needs to understand the capabilities of some of the events. But this is, I think, one of the benefits of serverless that some people don't necessarily see when they're just thinking of, a Lambda function or a message on a queue or a message on an event bus. Part of this serverless amazement, I think, is how, because you're getting rid of so much of that undifferentiated heavy lifting, you can get your business far more involved in your architecture. And event storming is one of those ways. There are other ways as well. When we look at step functions, for example, mentioning that earlier, just having a visual workflow that you can give to a business process designer to visually look how transactions may work. So yeah, this is why this EventBridge Storming really appeals to me, because anything that gets us closer to the business and gets architects and developers and designers and business people together is hopefully going to land up being better applications.
Definitely. And when our events are rooted in the business logic or the business wording, when an event starts to fail, if I say 20% of card success message, there's been a 20% reduction in payment success events, that means something to the business. The business needs to panic and figure out what's happening. Or if I say we're no longer capturing the user registration events, those events start to have real business meaning and people can start to understand what the impact is a lot easier than the more granular events. And of course, these are cross service. Inside of services, you might still work in an event-driven way, and it's going to be a bit more micro, but across those services, working in business language and that shared lexicon of business language. And we'll talk about when words have different meanings to different teams, which is one of the things this helps to capture. But having that shared language really helps your teams. And having that in a discoverable way, things like the EventBridge schema registry or the open source project, it's called EventBridge Atlas, really help us to have a browsable library of events, especially in a large organization, that enables teams to, again, work more independently. But if we work through the first step of this EventBridge Storming together, the first step is event discovery. Now, this is typically quite a chaotic moment. Everyone's, it's physical. We've got Post-it notes, we've got a very big wall, and we're writing down our events. And we don't want people to talk to each other at this point. We just want people to write down their events. We don't care about duplication. We don't care about different words. It's quite a messy section of the session, but this is where we try and capture really the majority of things. And every other step is sifting through that, grouping that to come to that clarity as a team and that consensus. So for our exercise today, I thought it could be interesting. I know the Serverless Espresso has done very well at the summits on its global tour. So maybe the Serverless Espresso can branch out into a coffee delivery system for developers. So I'm working in my office or I'm working from home. How can I order a coffee? It gets made by Julian and Ben at the AWS office. And how does it get delivered to me? How can we build that end to end? and there's probably some fun usage of AWS location in there. But what are the different business events of that workflow? There's the coffee being made, there's the order being made, there's the payment success. I'm giving some of them away to Julian. But if we take maybe just a couple of minutes, both of us working independently here, but just grabbing these event tickets, these orange tickets, and I've actually got one of these colors wrong. Domain-driven design, EventStorming has quite a strict rule about the different colors for the different things. The key thing is to have different colors and everyone to know what they mean in this context. But for instance, I could say order placed. We're focusing on the past tense and we're focusing on verbs. Placed being the verb, so order placed, item dispatched, Amazon Prime delivery delivered, whatever it might be. So should we add a few of these, Julian, and then jump into the next step?
Well, the sort of beginning would be order placed, the end would be order delivered.
Yep, just yell them out and I can write them.
Yes, I mean, could we also, I mean, are we even things, how much granular detail would we need to, payment success, payment failure even?
Yep.
Create even down something to do with the menu. Yeah, we could order beans. That sounds good.
Menu updated.
Menu updated. What else could we have? Email confirmation or email confirmed.
Sent maybe.
Yeah.
Yes. Any others?
Anything. If somebody calls up and there's an issue with the order, what kind of event would there be? A order issue tracked. Yeah. Or order issue raised even.
Raised. Yeah. Sure. In AWS Connect. Okay, I'm giving away this AWS services down there. What else could there be? Maybe there's going to be some sort of rider, right? Picking up these orders and dropping them off. I don't know who from the DA team is going to be doing that, but
we'll say Eric. Eric's going to be the.
I was going to say Eric too.
Order collected, good one. Yeah.
Yeah, order collected, order dropped, as in delivered.
Delivered.
Yeah, maybe delivered.
Coffee's been dropped.
Maybe rider. Maybe it's completely peer-to-peer. What I don't mean peer-to-peer. I mean
order accepted or something. Yeah, or rider registered. Yeah,
rider registered. So maybe these aren't employees. Maybe they're just registering straight in the app. Order accepted. User created.
Yeah.
Go ahead.
Even a rider available.
Yes.
And then even rider not available.
Yeah, maybe it's rider shift ended.
Yep.
What else could there be? Store closed.
Yep.
Store opened. It's easy when we just revert them. Anything else you can think of?
Order cancelled.
Yeah. Refund issued.
Yep, that sounds good.
Cool.
I mean, we could go into a whole other microservices of loyalty points and all things like that, but we may need weeks.
Loyalty card registered. Let's just do that for now.
Yeah.
That's the type of issue. So a lot of sort of chaos would ensue, especially imagine doing this for half an hour with a room of people who are very passionate about coffee. It's going to get very busy. And maybe you've called them orders, but I've called them, trying to think of a good name. Or maybe it's not.
Product placed or something.
Yeah. Baskets placed. Baskets confirmed. Means a very different thing. It's a very different word. Digging into why those differences are there. We don't do it right now, but as we start to put them in order, we'll start to see. Maybe we've said user created there, but maybe we've said user. I've said customer created there.
Customer signed up or something.
Yeah, exactly. But you can notice as different teams call them different things, actually having some clarity on these, and where the same things means different things to different people. We've said order issue raised, but maybe bean order will be issued. It's quite confusing, but they're different teams, and maybe it's not actually an issue if the code base is fully decoupled. So figuring out where there's different words that mean different things to different people can actually be quite important. And how we store the information about orders in the fulfillment part as opposed to the marketing part, and maybe that's an interesting one to send. Maybe
Xavier, I'm sure I've absolutely butchered your name. Apologies for that. Yeah, we could have a whole tracking microservice of order about to arrive, or order nearby, or yeah, we can go. Thanks for joining us from YouTube, by the way, and appreciate you joining in and giving us some more events.
Yeah, order near customer. Very cool. Okay, sounds good. So, and yeah, maybe that will lead to a push notification sent. Do that. Cool. So again, there'd be more chaos. It's quite an arbitrary example, but that moves us to the next step. So temporal sequencing, a fancy way of saying putting things in order. And there's going to be different flows. And if things happen at the same time, we can put them vertically on top of each other. But I guess you said, okay, order placed will probably be the start. But actually before that,
menu updated, yeah, or user created. There's a menu updated, the store opened.
Yeah. Menu updated, yeah, store opened, very good. Store opened is probably going to happen. They're kind of semi-dependent, so I'm going to put it like this. Menu updated, yeah, that could happen anytime, there-ish. Order placed, well, payment has to succeed, I guess, before the order is placed. Or maybe not, maybe payment happens after, maybe we put a hold on your card and payment happens after your order is delivered. Order issue raised. Which is a confusing way of us saying when a customer complains.
That'll be after the order is placed, I would think.
Has to be after the order is placed. Beans order issued can happen any time. Order accepted happens after an order is placed. But maybe, actually, I feel that payment happens after the order is accepted.
Yeah, could be.
Order cancelled has to happen after it's accepted. Order collected has to happen after it's accepted. So put that out of that happy flow. Rider registered happens sort of as an independent flow. Refund issued probably happens after
order cancelled or
issue. Oh yeah, well, and after order cancelled, so let's shift that over here. Customer signed up. So yeah, here's an example of, okay, customer signed up, but actually we have user created, and I've worked with clients where they have both customers and users. Confusingly enough, not all users are customers. And not all customers are users in that context, which is very confusing. But this is probably in our simple example, where a nice new startup that's got quite a simple architecture, we're probably going to decide between us which one it should be. So what are you thinking, customer or user?
Yeah, maybe customer is a more customer-centric view for your business.
That sounds very Amazon. I like it. Order delivered has to happen after the order is collected. Store's going to close at some point. Rider shift ends at some point. Order near customer happens before it's delivered, you'd hope. Push notification sent happens, let's say, simultaneously. Email confirmation happens at the same time as payment success. Rider is available, happens at any time. Marketing survey sent, let's say, happens a month after they order at least one coffee. Refund issued after that. Payments failure can happen sort of at any time. Rider has to register before a rider is available. The beans issue is kind of separate. Rider shift ends happens, yeah, at some point over here. And again, it would be a more complex picture in a real application. But you can start to see, we had an argument over that bit. We're starting to see some consistency, starting to make a bit more sense. It's a bit less confusing. And again, we kind of did it together, but everyone's going to have been putting this on independently, different people from different departments with different problems. So actually will probably be more of a distributed graph of different tracks of things. Again, it's going to be a bit of an arbitrary example, so we'll see how well it works. But that takes us through that temporal sequencing. The next would be trigger detection. So figuring out the commands and the actors involved. But I think today, just conscious of time, let's skip directly into the categorization into aggregates. Now, aggregates are another name. We could view them as entities. Aggregates is a domain-driven design term, meaning a collection of entities. But for now, let's just focus on the nouns, the names of things. So what do we have? We have customer. We
order.
have order.
Store.
And you notice I'm putting these near the events they relate to.
Yeah.
Now,
rider.
if it happens, the rider, you're down there.
Payment.
Payments.
There's sort of some notification part, email and push notification.
Yeah.
Beans.
Make that push. Beans. Exactly. And let's add, I know we've got store, but we'll add it again because it's quite far away. We've got this idea of a survey. Again, we've got the rider, which we've had, but it's far away. We've got an issue or an order issue. We've got a refund. We have a loyalty card. And maybe I'm just going to add another one to make it more interesting. Loyalty points. Ooh. Loyalty points spent. Loyalty card, loyalty points. Again, we've got order appearing a few times. I'm going to drop it there. We've got our payments, email, confirmation. I think that's most of them. We've got a basket. Well, we decided we weren't going to go with basket, right?
Oh, I think Ben may have got a... No, he's still there. Sorry, I thought it just went mute. Yeah, we didn't go with basket. We what did we...
So yeah, we went with order instead. So
order,
we decided we'll get rid of basket. But maybe, you know, we're on a website where they can buy other things. This is just one part and it could be interesting, but we'll remove it for now. We've got our menu. Okay, so it's a good collection of entities. And again, we're rushing through it. It's quite an arbitrary example. And I'm just thinking if there's an interesting, maybe, yeah, let's leave it like that for now. So we've categorized into our aggregates. Now it's about grouping together events by avoiding dependencies. So we want to try and bring parts of this, we want to bring some groupings of these events that avoid dependencies. We want independent microservices and independent systems. So we don't want a big mixture of customers and orders interacting across services. We want to try and group things together, which sounds, it's going to look a bit abstract doing it in this kind of small example. It's going to look a bit more of an art than science, but hopefully it will help us keep going forwards.
But from our perspective, already things like you would have a rider management service and a loyalty point service. Is that the kind of thing you're thinking of?
Well, here we just want to group together our different bounded contexts. So bounded context, and again, we're kind of overusing the phrase in such a small example, but bounded context in domain-driven design is an area where a term can be used ubiquitously. So order only means one thing in that area. And then in bigger organizations, when you have less language consistency, it's super useful. Here, we're just trying to think of the different groupings of events. We're going to call them bounded contexts, but these different areas of the system. And each one of them, we'll see later on, may have one or more microservices. But the point is that that area is logically consistent in terms of language, and also can probably have one team managing those microservices, especially in a small example. So if we were going to take, and actually, you know, being realistic, in a larger system, let's say we're building a cafe management system for stores that have coffee shops and restaurants and other stuffs, this would probably all be one bounded context. But we're going to try and shift some stuff. So that,
in fact, I think that's an interesting point, is to sort of zoom out as much as you can, as early as you can. Even my comment, and I was sort of being deliberately flippant of thinking about microservices. This isn't the stage actually to think about microservices yet. You are trying to think of the bigger picture, and some of your bigger pictures may have 3, 4, 5, 10 microservices that actually eventually make up part of it. But we're trying to sort of stay as big a picture as we can, and then eventually hone down.
Yeah, and let's say we grouped this part, for instance, that would then encapsulate, this could be multiple microservices, but this area is going to emit events, it's going to retrieve events, and it's for those teams to decide how they architect inside of there. But let's say, issues and refunds, I don't see any dependencies really on anything else. So that issue tracking, that refunding, I think we could logically group together. That customer sign up feels very independent of the rest of the flow, as does the rider sign up. So maybe they're going to be in one group, maybe separate groups. That rider availability, though, feels very tied to that rider concept. That menu management feels completely out of this flow and completely independent. That bean ordering, again, feels, if I remember how to use this tool, feels very independent. All of this is happening. No one cares about the store. We just need to know if it's open or closed. That store being open, and again, we're not just grouping by the noun, but it's a useful way to look where nouns appear repeatedly. It's a good tip. Then we have this order flow, which feels very linked. And thinking about state that we're passing can be quite useful. So an order is being placed, an order is being accepted, an order is being collected, an order has a customer and it's near that customer and an order is delivered. The one thing that doesn't involve the order is that payment, which can often flag that as a potential candidate to jump out of the flow. But in such a small example, I think we would probably leave that altogether because it would be a bit oversplitting. That loyalty management, although loyalty points will be used as part of that payment, and probably we would have put that here if we put that into order. That feels like that can jump to the side. Email confirmations, again, it's not part of that core flow. You can sort of see some grouping filling out, and it looks like I'm being a bit arbitrary here, and I kind of am being because it's quite a simple example. But you're starting to see some different groupings. And then we can start to put groupings around these different areas. Ooh. It's always fun editing diagrams in front of people. Let's drag this here. And you probably hear my computer's CPU blowing up. And drag this here. And again, a bit of an arbitrary example, and we have a lot more democracy in how we're doing it. Marketing feels independent. That rider shift feels like it belongs with the other rider related things. And you know what? Let's say we're a small company and this is all marketing team related. So we're going to group this together. It then comes to naming those bounded contexts before we name those microservices. So often a bounded context can be just named after the entity if it only involves one entity. This can very easily be called customer. This could very easily be called beans, but I guess we're going to order more than beans, so it could be called supply. And we'll do things like order cups and milk and the various other parts of coffee making that I don't understand. This could be rider. This could be loyalty. This could be customer support. I'm trying to think of a better way. Issue, refunds, issue, trying to think. Let's say customer care for now. And this lets marketing, because it's surveys and notifications around orders. Again, slightly arbitrary, but you can see we're starting to create some groupings and menu management actually. Let's say that is again its own group. Now, each of these can have an independent team or actually teams to build those systems. But inside of there, we might have one or more microservices. And you'll notice that probably, if we've done this well, let's see if we can find a good example. So actually, we've oversplit because it's quite an arbitrary example. But let's say customer complained, and make this related to the customer. The interesting part of putting this as an example is we have the same entity appearing in multiple bounded contexts, and that's not necessarily a problem. The fact it's appearing in such a different business process and related to such a different flow actually means that we probably want to store different data about that customer in a different way. This is going to be a user authentication management service. It's probably going to be under the hood Cognito doing mostly the social authentication for that user. Whereas a customer care team are probably going to track the credit card fingerprint to do fraud detection. They're probably going to track other complaints this customer has made. They may be even going to track the address. I know Deliveroo have a system where if the same household keeps asking for refunds, they sort of mark that household as suspect because they're probably just asking for free food repeatedly. So this is probably going to track some other elements of the customer that this area doesn't care about. And the best structure for that data about that customer can be quite different in the customer care section than it is in the customer management, the authentication section. So when there is the same entity appearing in multiple bounded contexts, that probably means we need to store the data differently. And one key point is, even if we only have one microservice per bounded context in this very simple example, we are never sharing data. So no data from the customer, let's call it customer management to make it clearer. No data from the customer management section will be shared with the customer care section. Instead, whenever a customer signs up, that event will go onto the event bus, and the customer care section can choose to store what it actually is interested about a particular customer. So different bounded contexts don't share one big database. They manage their own databases and their own store of data. And we purposely duplicate data, and it's for those systems to maintain the data in the way that they need to. Now, you could go full on to event sourcing, which is a slightly different approach, but if we just had a simple event-driven architecture, those events would go onto the event bus, and then different teams can choose to subscribe to events and store data about those events as they need to. But that does mean that events need to have, in their context, all the data that other teams are going to need when handling that particular event. And that's kind of skipping ahead to the event schema, but what we're starting to do is build that event schema to have the names of those events, and also we're going to start to think about the attributes those events should have. Any questions at this point, Julian?
No, I think we're good. I think we're
good. Well, then we can keep powering through. So we have our set of bounded contexts, we have our set of events. There will then be, in this very, very simple example, it's just going to be one microservice probably per bounded context, but you might view that we have a payment service and an order service. And again, it doesn't always relate to the nouns, but in very simple examples, it kind of tends to. And both those services are in one bounded context. They can share code, they can have one team behind it, and they're going to be pushing events to the event bus that other bounded contexts and other services of bounded contexts will consume. So if we kind of imagine, and this is going to be a little bit rough, but if we kind of imagine bringing this a bit like this, and let's say this here, this here, and this here, you can then, and okay, let's just cheat a bit with this one. And you can see my architecting skills are rusty. We drop that here. We can then drop a big event bus through, and let's say we make that whatever color EventBridge is. I think it's kind of a purple. Oh, it's definitely not kind of a purple.
Reddish, I'll be going for.
Reddish.
There we go. That's it.
And then we can, it's almost exactly it, isn't it? We can then have each of these microservices pushing events onto that bounded context, onto that event bus. And others can then consume from it. But it's a very big simplification, but there'd be one microservice in each of these bounded contexts, one team, but that event schema, order canceled, loyalty card registered, that's that shared interface between the teams. They don't share code, they don't share databases, but they do share that schema of events. And kind of jumping forward a little bit further, we've created that single event bus. We would then store that schema of events in something like the EventBridge schema registry, maybe using something like Atlas, EventBridge Atlas, the open source project I mentioned, to make it a bit easier to navigate.
Yeah. But the author of EventBridge Atlas has just joined the Serverless DA team, so expect plenty more from him, Dave Boyne. We're happy to have him on the team. So yeah.
Yeah, I was very happy to learn that last week. He seems, and that was maybe day 3 for him, or it's always day 1 for you guys, but yeah, he seems to be settling in well.
So one question. Yeah. For instance, you've got the order / the service above, the order and there were two, the order and the payment service. you wouldn't, that bounded context may have multiple events that flow onto the event bus and then get picked up by the different microservices within that, or would you have a separate event bus within that that bounded context?
Well, in this very simple example, we would definitely just have one event bus. It's a custom event bus rather than a default. In our larger projects, actually, these start to become AWS accounts and in AWS organizations, kind of account per service, but actually it's more account per context for us because we have maybe some smaller microservices inside. And sometimes we've put event buses inside of each of those. There's still one event bus to rule them all that they are all pushing to, but then they can have their own sort of granular events inside, and also there's multiple servers inside one context can consume that event. It gets a little bit complicated when you're talking about this many AWS accounts. EventBridge has a very good feature that stops just an event repeating forever. But that also means that if you're hopping from one account,
I think it's fair to say that you should start with one custom event bus. Only when you start getting quite big or more complex with multiple accounts should you start introducing. As my comment was a sort of devil's advocate, there's no reason to have separate event buses within each of these bounded contexts. And even within a bounded context, you can still send and receive events to the single custom event bus. You're not sort of, so your arrow that you created could be multiple arrows back and forth, for example. It doesn't have to.
Yes, it would be multiple arrows back and forth. There might be some events that are only in the context of that team and not part of the shared schema. So in terms of like information hiding, we don't need to know all the different events that happen when notification, a cross-channel notification is sent to all users' devices. That can stay inside. So sometimes some advantages, but yeah.
But also they may, at this stage, we don't quite know how this is going to grow. So I would also suggest starting with having events more publicly available, because we've had a loyalty card option. We may have a VIP users lane or something like that. So, a new microservice may be able to then consume events from the loyalty service, and the loyalty service doesn't need to even know about this. And, looking at the schema, finding what there is, new business comes up with some whole cool new way that you can engage your customers. So yeah, I would err on the side of not hiding your events unless you specifically need to, because you don't know what's going to happen in the future.
And exactly. And let's say me and you are building the loyalty system, and Ben and Eric are building apparently this is called the container. That sounds very bad. Order management system. We don't actually care if they're using an event bus in their area. All we care about is the events that are being published and consumed. And this works really well when you're scaling up many engineers to actually, yes, you get the advantages of loose coupling, but also just cognitive load. We can onboard a new developer just into this world, this very simple world where there's going to be a very small DynamoDB database, a couple of lambdas, step function, but they don't need to know about all of this world. It gets even more chaotic, let's say. Yeah. So yeah, the cognitive load for new joiners, people new to technology, but also like for developers, it's a lot easier to build a great system when you don't have to think about everything. That encapsulation and that reduction in cognitive load is definitely a huge benefit.
Ben, I hate to say time just runs away from us. We could carry on doing this for another whole hour. I think this is fascinating, and we sort of got a good example here, but we're scratching the surface. But there's so much more we can discover. Where can people go to find more information? It's NPE did ask, suggested literature to learn EventBridge Storming. I did put the link to serverless transformation up on the slide. Anywhere else people should go to learn more?
Yeah, so on the EventBridge Storming, that particular variant around variant's a bad word these days, that particular version around building event-driven architecture in AWS, go to Serverless Transformation blog, you can find it there. I'm completely blanking on the name of the inventor of EventStorming, which is just that extension to domain-driven design. If you Google EventStorming, the Wikipedia page definitely has his name. It's very bad, I can't remember it. He has a very good masterclass that I think he hosts in London or remotely now as well. So you can definitely read about that there. And the domain-driven design book, which I think is called Domain-Driven Design. It's a blue copy. Eric something is the author. That's also a really good reference, all those domain-driven design concepts. Yeah, I think that's everything.
Perfect. And Ben, thanks so much for joining us. Ellaby Ben, that's your Twitter handle, correct? I haven't got that wrong.
Yeah, I think so, yes.
Yeah, co-founder of Alios. Really appreciate you taking the time to do this. I think this is a great sort of collaborative think people can do too. On the one side, doing the event storming, and then I love the concept of the minimal viable migrations. So thanks so much for taking us to the next level and learning about events. And yeah, I get to see you in Berlin in 2 weeks' time. And yeah, for the people watching live, thanks so much for joining us. And the people who are watching after the effect, thanks so much. Have a good day and enjoy the rest of your